Okay, so I guess some of you must know about additive manufacturing. You probably know it as 3D printing, and it's the process of layering material one on top of the other to create objects. What most of you probably don't know about is large-scale additive manufacturing. It's a similar process, but the only difference is that it's scaled up. So the materials used are concrete materials, construction materials, and of course the resolution is much smaller. There is one of these systems which is called D-Shape, and it's this gigantic 3D printer 6x6 which can create structures that are complex as the one you can see, concrete structures like that. How does it work? Well, basically it's binder jetting. It's one of the 3D printing technologies, the 3D printing technology, where there is layers of sand that are deposited, and on top of them you deposit a binder, and once you create the whole structure, you then start cleaning it out, and basically you have your product. It's a very old technology. It's the first one called 3D printing, and it's been invented in the 90s. The only difference in the D-shape process is that it's scaled up. So you basically have a huge printer head, and of course the cleaning process is way harder because you have to remove all the sand. Well, how do I come into this picture? Well, basically I met the guy who invented this during my master thesis. I went to be with him for a couple of weeks. We did some printing together and stuff like that. On the way back home, I took some material and I tested it for him. It turned out that the material was actually quite good. It was very similar to Portland concrete strength-wise. It was fast curing. It had really good bonding properties. It could bond pretty much with anything, wood strands, you name it. You can put anything in it. However, However, on the other side, there is the problem that the layered material was way weaker than the same mixed material. There was not so much predictability. The layers were completely different, and there was some additional problems, like problems with water and so on. But however, the material was really good, and already back then I was thinking this material would be really great for formwork. Formwork is extremely expensive, especially if you have complex forms. So I started thinking about this idea. I took the lightweight concrete blocks, which are a typical thing used for construction, where you erect a wall with these blocks that are really easy to handle, really easy to put together. What you basically do, you stack them on top of each other, then you pour concrete in the side, you reinforce them, and then when you pour concrete, when it cures, you basically get a structural grid within. I have some time. That's rare. So basically the idea is to pass from a rigid block system that is very linear to one that is completely freeform. You have all the advantages as the other one, but on the other hand you have a complete form possibility. So if you take an example structure, a tunnel that has a really curvy shape, it would be extremely expensive to create a formwork for that. It would be also stupid in a way because you would create it for only one project. But if you want to print it, you can just cut it into pieces, you print it, you clean it, you put it together, you reinforce it, and you have the whole structure with a minimum amount of supports. Once that is done, you just pour concrete inside from the top, you let it cure, and you get a strong structure that has all the benefits of any other cast concrete structure, but it also can have other advantages, and it's way cheaper. So my idea was to create this product, which would be a 3D printed lightweight concrete formwork, which would be really cheap, would have same cost for all complex shapes, would be lightweight, and would have many advantages. But why limit myself there? I think we should go even more. We should create layered concrete materials. We should create many materials that function this way, that have specific functions that are completely different than mixed materials. There are many aggregates that are used today in concrete to lighten it, to create some different kinds of concrete. They use from expanded polystyrene, they use palm shells, they use everything. They just throw everything into it today. But basically, thinking in a layered fashion, you have a powder on one side and you have a liquid on one side. just think about the possibilities that you could put into this powder, or you could put into this liquid. For example, you can put some conductive materials and create a conductive concrete if you need it. This is just an example, but there are millions of ideas. This is just a beginning of a new science. Thank you very much.